everybody. In this video, we're going to talk about how to divide fractions. So let's start off by talking about how to divide fractions and whole numbers. So remember, there's two different ways that you can think about division. You can think about division as sharing division, where you take the amount you start with and you divide it up into a certain number of groups equally. Or there's measurement division, where you take your starting amount and divide it up into groups of a certain size and you figure out how many groups there are. And if you're dividing by a whole number, the easiest way to think about division is with sharing division. So if I have 1/2 divided by 3, I'm going to take the amount 1/2 and I'm going to split it up into 3 equal parts. So if I split this up into 3 equal parts, I have 1, 2, 3 equal sized pieces within the 1/2 amount, and I need to figure out how much one of these groups is. So I'm going to split the whole distance from 0 to 1 into pieces that are all that size, and when I count the total number of those, it looks like there's 6 altogether. And so the size of one of these pieces is going to equal 1/6. Now, if you're taking a whole number and dividing by a fraction, the easiest way to think about it is with measurement division, which means that I'm going to take the number 3 and I'm going to say, how many groups of 1/2 can I fit inside of 3? So I can definitely fit 1 group and 2 groups and 3 groups and 4 and 5 and 6. And so 3 divided by 1/2 equals 6. And it makes sense that we got 2 different answers here because division is not commutative. If you switch the order of division, you're not going to get the same answer. However, the answers will be reciprocals of each other. So a reciprocal is basically a fraction that's been flipped upside down. So if you took 1/6 and you exchange the numerator and the denominator, you would get 6/1, which is the same thing as 6 wholes. And so if you switch the order of division, your answers will be reciprocals of each other. So most of the time, you're not going to be dividing by whole numbers. And so let's talk about how you would divide a fraction by a fraction. So if I had 9/4 divided by 3/4, well, 9/4 is going to be this mark right here. And because I'm dividing by a fraction, I'm going to use the measurement division model. So I'd say, okay, well, how many sets of 3/4 can I fit inside of this distance from 0 to 9/4? Well, I can definitely fit 1 group of 3/4, and I can also fit 2 groups, and it turns out that I can fit exactly 3 groups of 3/4 into 9/4. So my answer in this case would be 3. Now, if I had 11/4 divided by 3/4, 11/4 is this unit right here. So I would still be able to fit 3 whole groups of 3/4. However, I would not be able to fit 4 because a 4th group of 3/4 would go to this mark, and I'm just at 11/4, not at the 12/4 mark. So I know that my answer is going to be 3 whole groups of 3/4, and then I need to figure out how much of a group of 3/4 this space is. So an entire group of 3/4 would be this space, and the amount that I have is 2/3 of that space. Because notice that there's 3 little sections here, and a full group has 3/4, and the amount that I have is just 2 of those 3. And so 11/4 divided by 3/4 is going to equal 3 and 2/3. So how do we calculate this number, especially if our numbers are more complicated? Well, if you look at the first example we did, notice that 9 divided by 3 equals 3, and 4 divided by 4 equals 1, and 3/1 equals our answer, which was 3. And if we do the same thing here, 11 divided by 3 can't be divided evenly, but we could write it as 11/3. And 4 divided by 4 is just going to be 1. So you'd have 11/3 divided by 1, which just equals 11/3. And notice that 11/3, if you convert that into a mixed number, is going to equal 3 wholes and 2/3. So one way that you can divide fractions is to just divide straight across. Just like when we multiplied fractions, you can multiply straight across. When you divide fractions, you can do that as well. Another example where you don't have the same denominator might be one like this. So if we divide straight across and we say, well, 15 divided by 3 is 5, 16 divided by 4 is 4, we get the answer 5/4. And this makes sense because if we have 15/16, that's this mark right here. And if we want to divide it into groups of 3/4, well, we have enough to make one full group of 3/4 because 3/4 would be equal to 12/16. And so this distance right here would be one full group of 3/4. But we don't have enough to get up to two groups of 3/4 because we would have to have 24/16, but we only have 15/16. So if we imagine a full group having 12 more 16ths, well, the amount that we have is just 3/16. So if we need to have 12/16 and we only have 3, well, that means that we're going to have our one full group that we have here. So that's going to be 1. And then we're going to have 3 out of our 12/16 that we would need. And if we reduce that, that's 1 1/4, which is the same as 5/4 converted into a mixed number, which would also be 1 1/4. And so this would be a number line way of showing that you can divide straight across when you're dividing fractions where the division works out nicely. However, sometimes the division doesn't work out nicely. Like, for example, if you have 1/2 divided by 3/5, well, 1 divided by 3 is 1/3, and 2 divided by 5 is 2/5. And that makes the problem more complicated, and it doesn't really simplify it down to a single fraction. So the way that you can do this is you can create common denominators, because if you have common denominators, then the bottom part will divide out to 1. So when I look at the denominators 2 and 5, the least common multiple between 2 and 5 would be the number 10. So I'm going to convert both of these fractions so that they have common denominators. And 1/2 equals 5/10. 3/5 would equal 6/10. And if I do 5/10 divided by 6/10, well, 5 divided by 6 is 5/6. 10 divided by 10 equals 1. But anything divided by 1 just equals itself. And so that would equal 5/6. And the reason why this method works is because 1/2 and 5/10 are the same amount. Same thing with 3/5 and 6/10. And when they have common denominators, it's much easier to divide the fractions. Because if I had 5/10 and I wanted to figure out how many groups of 6/10 I would have, well, a whole group of 6/10 would go to this point. So I know that I don't have enough to make one full group, but I can make 5/6 of a group because it would require 6/10 to make a full group, and I only have 5 of them. So that's one way that you can divide fractions as well, particularly if it doesn't work out nicely to divide straight across, because a lot of the times that won't work out nicely. And then the last method that you can use to divide fractions is probably the one that you learned in elementary school. It's definitely the one that I learned. Like, I didn't know that you could divide fractions straight across until I think it was actually in college that I learned that. Because most of the time when you learn to divide fractions, the method that you learn is to multiply by the reciprocal. So the reason why it works to multiply by the reciprocal is because if you do 1/2 divided by 3/5, the answer that we're looking for could be rewritten as a multiplication problem. Because remember, every division problem is in a fact family that also has a set of multiplication problems. So we could rewrite this as 3/5 times what equals 1/2, because that's basically what the division is saying. And if we multiply by the reciprocal of 3/5, So in this case, the reciprocal would be 5/3. Well, 5/3 times 3/5 cancels itself out because 5 times 3 is 15, and 3 times 5 is also 15, and 15 over 15 is just 1. And so that tells us that our question mark equals 1/2 times 5/3. And that would give us that same answer we got on the last slide, which is 5/6. So this is the idea behind multiplying by the reciprocal. But this reasoning isn't necessarily something that you can explain to your students when they're learning fraction division for the first time, because your students don't know algebra yet. And this process of multiplying both sides by the same thing would be something you would need to explain before you could explain this reasoning. So this is why I would recommend teaching the other methods to help your students conceptually understand how to divide fractions. And then you can teach them the multiply by the reciprocal method as a shortcut. And when you teach your students this shortcut, it's important to remind them that it's the second fraction that you find the reciprocal of. So there's lots of different mnemonics you can use to help your students remember this. One of them is keep it, change it, flip it. So you keep the first fraction the same, you change the division to multiplication, and you flip the second fraction. Or another way that I actually like even better is called the zigzag method. This is something that one of my students taught me. And I love it because it keeps it really, really simple and you don't have to worry about which fraction you do the reciprocal of. So the zigzag method basically says that you take 1 and then you multiply by 5 to give you the top number of your answer. Then you do 2 times 3, and that gives you the bottom number of your answer. And it basically gives you the same result as multiplying by the reciprocal, but it makes it really easy because you don't have to worry about, well, which one do I flip? And so that can make the process a little bit easier for your students. So that's how you divide fractions. If you have any questions, let me know.